Okay, so let's go ahead and prove the derivative for f of x is equal to sine of x today. All right, so the claim is that if f of x is equal to the sine of x, f prime of x is equal to cosine of x. Okay. All right, let's go ahead and seek to prove this derivative statement here today, using, of course, the definition of the derivative as a limit. Okay, so f prime of x is going to be equal to the limit as h trends to 0 of the sine of the quantity x plus h minus the sine of x, all, of course, divided by h. Okay. Now, I am going to be using the sine of a sum expansion, which I have proven in another video, so feel free to access that. But I will go ahead and establish it right here. The sine of a plus b, okay, is going to be equal to sine of a cosine of b, and we should actually say sine of a plus or minus b is equal to sine of a cosine b plus or minus cosine a sine b. Okay, so let's get that in a box. Okay, again, I have a proof of that available on another video if you so desire to check that out. Okay, so here we go. We're going to have the limit as h trends to 0. Going ahead and expanding this using our formula, we're going to have here sine of x, cosine of h, plus, right, because it's plus, cosine x, sine of h, minus, of course, sine of x. That's not going anywhere. All right. All of that, of course, over h. Okay. Very good. Well, the first and third terms of the numerator have a sine of x in common. So I'm going to go ahead and factor that out. It's going to give us the limit as h trends to 0 of sine of x times the quantity cosine of h minus 1, okay, plus cosine x sine of h, all of that now divided by, of course, h. Okay. Okay. Looks good. Now, we have to realize a couple things here. Firstly, the limit of a sum is the same thing as the sum of limits. Okay, so let's get that in the box there. This is a property that can be proven using analysis, using a discussion about neighborhoods around a point. And so the proof for this statement is actually quite technical and goes beyond the scope of this video. Perhaps in the future we will present a proof of that. But for now, I'm assuming that the reader, or excuse me, the viewer is comfortable with this limit property. And the limit properties are quite convenient, pretty much as we would want them to be. Limit of a sum, same thing as a sum of limits, limit of a difference, difference of limits, limit of a product, product of limits, limit of a quotient, quotient of limits, limit of a function of a function, function of a limit of a function. Basically, as we would want them to be, so they are. Okay, so keeping that in mind, we have the following. We've got the limit as h trends to 0 of sine x times the quantity cosine h minus 1. Okay, all of that over h. Okay, plus the limit as h trends to 0 of cosine x sine of h over h. Okay. Now, it's worth pointing out that the limit here is dependent on h. So this factor here, sine of x, can actually come out to the left-hand side of this limit. Moreover, the cosine x can come out as well. Okay, and I'm going to have the following: sine of x times the limit as h trends to 0 of, well, here we go, cosine h minus 1 over h. And then over here we're going to have plus cosine of x times the limit as h trends to 0 of sine of h over h. Okay? Now, a couple of limits that are typically provided in any introductory single variable calculus class are these. Now, I'm going to put them in a box here. The limit as h trends to 0 of the cosine of h minus 1 over h, this is going to be 0. Okay, there's one of them. And the other one, of course, is the limit as h trends to 0 of the sine of h over h. This is going to be 1. Now, the proofs provided for these are both geometric in nature, and I will post a video, future video, that demonstrates the veracity of both of these claims right here. But for now, I'm assuming that since the viewer is looking on YouTube for a proof for the derivative of sine of x, that the viewer has taken an introductory single variable calculus course and is therefore comfortable with these two typically provided limits in the class. Well, if that's the case, then this goes to 0, and sine of x times 0 is 0. And this goes to 1, and so we have, at such a juncture, finished our proof. Okay? So there you have it. Let me know if you have any questions, comments, and concerns. We certainly hope that you appreciate the work we're doing here. We seek to teach the why of mathematics in addition to the how. It's important that that those who study math understand not only how it works, right? You know, plugging in numbers into a formula and the like, but more importantly, why it works. To understand why it works is to really understand the foundations of mathematics and to, in such a way, enhance deeper understanding. Let us know if you have any recommendations for future content. We're certainly open to all recommendations. We love proving statements around here, as many as we can, as we can get our hands on, quite frankly. Have a great rest of your day, and we will see you in the next video.